So we have discussed about the read after write hazard. Now we will see the second category of hazard, that is what we call write after read hazard. Now what this write after read hazard mean? Let's try to understand from this same example I1 followed by I2. But we can say that I2 tries to write a destination before I1 reads it. So what will happen as a result? So I1 will get basically I1 will read incorrect value. Now you see this particular explanation is little bit confusing because I am saying that I1 is followed by I2. Then how it is possible that I2 tries to write a destination when before I1 reads it? I1 must be completed. I mean I1 must be before I2, right? So execution of I1 must start from execution of I2 at least. That's for sure. So in this situation, if I consider that execution of I1 have a read of some particular source and execution of I2 have some write operation on the some particular source, then when the execution of I2 is running, how execution of I1 will not yet completed, right? So we cannot explain with the help of this type of example, because in this example, in case of read after write hazard, we have seen that we have a dependency between these two values. If anybody ask you, if give you two instruction and ask you that whether there is a data has possibility of read after write hazard or not, what you have to do, you have to just check whether the variable that you have updated in the first instruction is used in the second instruction or not. If it is so, then there must have a possibility to have a read after write hazard. It's very easy to detect, but it is not so easy to detect. So actually what happened, you see, this particular example, I mean the example of this particular situation is actually for the instructions under auto increment and auto decrement mode. Auto increment or auto decrement mode. Now what does auto increment auto decrement mode mean? It is an addressing mode which say that some registers will be automatically incremented after every iteration. So that increment instruction is already present hidden, I mean it's already given within the instruction itself. Now let us take a situation that you have a memory location. Okay, so assume that you have a memory location. and there is some certain set of certain set of locations are there which consider, which contain actually some instructions. Okay, and as a programmer, what you want to do, you want to read these instructions and somehow execute. So naturally this part, each and every memory location has some address. So let's just consider there is an index, and we can easily use that index value to fetch the instruction from the memory. So there are 4 indexes, and now you see that we have some register R1 whose initial value is suppose 0. Now you see, when it is 0, it is reading the instruction 1. Fine. It is reading the instruction 1. So it will read the instruction 1. I1 actually, not 1, I1. And after that, what will happen? After that, this 0 will be changed by R1 equal to 1, so that the next instruction can be read. And then after doing this, then it will read the instruction I2, something like R of, I mean, sorry, the memory of R1 in this way. So basically, you see what you are doing. This particular situation, this particular situation is reading instruction I2 from memory. And to do this, you need this one, and this is what? This is a write operation. That means to read the instruction I2 from the second location, you need to write on the register R1 first. And this is a situation where this particular situation is true. That there is an instruction that is trying to write a destination, it has to write it first before I1 reads it, because ultimately reading of this instruction 2 must be there, should be there. So before reading this one, this has been done. So this is a situation where we can have a read after write hazard. But you know, generally in our computer system, understanding read after write has, write after read hazard is not very easy, because from an instruction directly it is pretty difficult to realize the read after write hazard. Write after read hazard. Now, next, the third category that we have is what we call write after write hazard. Now, what does it mean? with respect to same situation I1 followed by I2, I can say that I2, or just a minute, let's take the same color again. I2 tries to write an operand before it is written by I1. The write up being performed in wrong order, naturally, leading leaving the value written by I1 I1 rather by I2 in the destination. Now, from this particular explanation, it is very clear that it is actually this write after write hazard is actually related with some conflict on the resource, right? Some operand. So generally, that's why this write after write hazard is not uh, doesn't actually happen in general computer. Even if it happen, then we not possible to express or show an example. So you can just remember the situation and you can say that this is the explanation for a write after write hazard.